Alright, this is Mr. Gillum, and today we're going to learn about the reciprocal trigonometric functions. And those would be cosecant, secant, and cotangent. These are different than the inverse operations, like sine to the negative first power, what we were talking about the other day. These are a little different than that. Okay. The cosecant, secant, and cotangent have relationships to sine. They have relationships to sine, cosine, and tangent. Okay, and so a lot of times if they ask you to find all 6 trigonometric functions of an angle, you list them in this order. Sine of the angle, the cosine of the angle, the tangent of the angle, and then you also list the cosecant of the angle, the secant of the angle, and the cotangent of the angle. All right, now the easy ones to remember that they're reciprocals are tangent and cotangent because they both have the word tangent in them. The ones that are trickier are sine and cosine, and they're reciprocals. Sine and cosecant go together. Cosine and secant go together. And so when I say reciprocal, I'm not talking about inverse function like undoing something in an equation. I'm talking about the same ratio but flipped over. So in this case, if I was talking about angle A here, in this triangle, the sine of A would be the opposite over the hypotenuse. So in this case, it would be little a over c. And the cosine would be the adjacent side, b over c. And the tangent would be the opposite over the adjacent, a over b. All right. Now I want to show you this over on the side before we do the second column. If I know the sine is the opposite over the hypotenuse, and I know the cosecant, and it's abbreviated CSC, I know the cosecant is the reciprocal of that, then the cosecant is the hypotenuse over the opposite. Okay, algebraically it looks something like this. The cosecant is 1 over the sine, so the cosecant of A, like that. And we know that, so through substitution, we would know that, let's use A, angle A. We would know that the cosecant of A would equal 1 over the opposite over the hypotenuse. So we have a complex fraction here. I really emphasize that this is the main fraction bar right there. And then if I wanted to get rid of the complex fraction, I multiply the top and bottom by the hypotenuse. And so as you can see, the cosecant of A would equal the hypotenuse over the opposite. All right. I also want to stress that yesterday we were using, like I said, we were using inverse sine. You can't type in the cosecant here the same way you type in inverse sine. In order to type the cosecant into your calculator, you would have to type in 1 divided by the sine of whatever angle you're looking at. Okay, so it's different buttons in your calculator. It gives you different solutions than the inverse sine. They're not inverses anymore. These are reciprocal trigonometric functions. Okay, so because sine and cosecant are reciprocals, I would know if I know the sine is A over C, I know the cosecant would be C over A. It's just a matter of the reciprocal. That's it. That's all it is. It's a reciprocal trigonometric function. This is the algebra behind it right here. Okay, so you can always find, if you forget which one's inverse, you can always figure that out. Secant is the inverse, the reciprocal of cosine. So it would be C over B. I have B over C, now I have C over B. And cotangent is B over A. All right, these are called the reciprocal trigonometric functions. All right, and so just practicing with them and getting familiar with them this year is going to help a lot in the years to come. So let's take a look here at the first problem. It says, find the values of sine of A. I'm going to leave a little more space than I did before. Sine of A, the cosine of A, the tangent of A. And I like to write them right in order. I know sine and cosecant are reciprocals, so I'm going to go ahead and put that cosecant lined up with the sine. With cosine, I'm going to write secant. And with cotangent, I'll write that right across from tangent. Okay, so now we've done this in the past many times. The only thing we're adding today is cosecant, secant, and cotangent. They're just the reciprocals. So if I know the sine of A, in this case, is opposite 8 over hypotenuse 10, then I know that is equal to 4/5. So immediately I know that the cosecant of A would be 5/4. All right, you see what I did there? I just did the reciprocal there. I know the cosine of A would be the adjacent side divided by the hypotenuse, 6 over 10, which is 3 over 5 in reduced form. So I know immediately that the secant would be 5 over 3. The tangent of A would be opposite 8 over adjacent 6. 8 over 6, in this case 4 over 3. So I immediately know that the cotangent of A would be 3 over 4. Okay. I want to stress too, sometimes they do ask you to find the decimal values, and usually it's a 10,000th is what you round to. I'm not sure why we've been doing to the 100th as far as the example problems, but a lot of times I ask you to 10,000th. Again, you don't type in, this is not second sine like you did inverse sine. This is, in order to type cosecant into your calculator, you need to actually take 1 divided by the sine. All right, in order to type secant in, you do 1 divided by cosine. In order to type cotangent in your calculator, you just have to type in 1 divided by tangent. Okay, they are reciprocal trig functions. They are not inverse trig functions. This is a different thing. Find the values of the six trigonometric functions for a 45-degree angle and a 45-45 triangle with legs that are 4 centimeters. Okay, so I'm a visual person, so what I'm going to start with is just a nice 45-45 90-degree triangle. It's a nice little sketch there. Obviously, these are the 45-degree angles on the side, and my right angle is here in the corner. And it says that my legs are 4 centimeters long. And so I know that since this is a special triangle, that if my leg is 4 centimeters long, then my hypotenuse must be 4 root 2. Because the 45, 45, 90, it's got special characteristics. Okay. And again, you could always do the Pythagorean theorem if you really thought it was necessary, but we know this special triangle rule. So those are my side lengths, and I'm looking for the 6 trigonometric functions for a 45-degree angle. Now, regardless of which 45-degree angle I pick, opposite of it is always 4, and adjacent is always 4. So it doesn't matter which one I pick, the values will be the same. So let's start with writing down the functions. The sine of 45 equals cosine of 45 equals the tangent of 45 equals, as well as their reciprocals. Cosecant of 45, secant of 45, and cotangent of 45. All right. Now let's take a look here at this guy. We want opposite over hypotenuse. So here's a 45. Opposite is 4. Or hypotenuse 4 root 2. On some of the papers that I've seen you turn in, I've noticed that people have left it as 1 over the square root of 2 after reducing. We need to go ahead and rationalize that. So we have, for sine of 45, we know that is root 2 over 2. All right. That would be my first trigonometric function. Cosine of 45, adjacent over hypotenuse. The adjacent side is 4. Hypotenuse again is 4 root 2. Instead of rationalizing it, since I started with the same fraction, I know that the cosine of 45 is going to be the same as the sine of 45 in this case, root 2 over 2. Okay. The tangent of 45, opposite over adjacent, 4 over 4, and equals 1. So the tangent of 45 equals 1. Now, you might be thinking, well, I can do this in my head. I can get the square root of 2 over 2. One of the nice things about showing your work on the sine, the cosine, and the tangent is that before you reduce, if I try to flip this fraction over, I'm going to have to rationalize again. But if I start with my main fraction, like right here, if I look at this one and I flip it over, I know that the square root of 2 over 1 is really just the square root of 2. So my cosecant of 45, I don't know what letters I just typed there. The cosecant of 45 would be the square root of 2. of the secant of 45, like I said before, since the sine and cosine are the same, the cosecant and secant will also be the same. Square root of 2. And the cotangent, obviously, the reciprocal of 1 is 1. The cotangent and tangent actually are the same in this case as well. So those are my 6 trigonometric functions, and that's where they come from. Let's take a look at another one here. It says we have a triangle FGH, and the tangent of f equals 5 over 12. Find cotangent of f and sine of f if angle G is a right angle. Okay, so I'm going to draw a picture here, and I don't know if it's to scale. I'm just going to draw a random triangle. Of course, your random triangle should always be a 90-degree right triangle. All right, and I'm just going to label it F, and it says angle G is the right angle. I'm going to call this guy G, H, and it says the tangent of F, so the tangent opposite, and 12 must be the adjacent side. Okay, so I know that opposite on top, 5, adjacent 12, and I know that this is a right triangle, so I know this side must be 13 because it's a special Pythagorean triple. Or I could use the Pythagorean theorem if I wanted to. Okay, but those Pythagorean triples do come in handy. If I know the tangent of f is 5/12, it's pretty quick for me to find the cotangent. It would be 12/5. Right? It's just the reciprocal. The sine, though, I do need this side for 13 because I need the hypotenuse. The sine of f would be the opposite, 5 over the hypotenuse, 13. So the sine of f is 5 over 13. All right. So drawing a picture and visualizing are going to be important aspects of what we're doing today. Again, I knew where the 5 and the 12 and the 13 were according to the information given to me. It says the tangent of f is this ratio. That tells me the top number is the opposite and the bottom number is the adjacent side. Okay? Let's take a look at one more here. It says find the values of the 6 trigonometric functions for angle T and RST if angle R is 36, R is 12, round to the nearest hundredth. Okay, so let's do it. We're looking for angle T. I do have an angle and a side length, so I know I can find all the trigonometric values that I need. Just for reference here, if this is 90 and this is 36, that leaves me 54 degrees for angle T. Might be important later. And so now we have to find all the trigonometric functions. And actually, we're running to the nearest hundredth in this case. So here we go. Let's do the sine of t first. The sine of t, or the sine of 54, would equal the opposite over the hypotenuse. So in this case, what I'm going to do is I'm going to say the sine of 54 equals t over, well, we're not going to actually be able to do this one yet until we have another value. It's eventually going to be t this side over the s, but we need to know what t is first. The cosine of 54 equals the adjacent side over the hypotenuse. Then that we can mess with, 12 over s. I can figure out what s is, and I can help figure out my side lengths. So I'm going to go ahead and do that. Cosine of 54 equals 12 over s, and I'm going to make this a proportion and cross multiply. S times the cosine of 54 equals 12, cross multiplying, and I'm going to divide both sides by the cosine of 54. 12 divided by the cosine of 54 is 20.4. It says nearest hundredth, so we're going to say 20.42. S equals 20.42. And so instead of writing 12 over S, we're going to write 12 over 20.42. I'm going to go ahead and put this value in here for S, 20.42. It's going to be necessary for the rest of our trig. 12 divided by 20.42 now is 0.58, actually 0.59. 0.59. Okay? Now that's going to help us to find our sine and go from there. So let's finish this up in class tomorrow. All right, we'll find the rest of them. That's it for today.